So let's discuss this question. The question asks you to accurately sketch at least one complete period of the curve. That's actually the trig function. You can see this function is different from the basic form. So the basic form for the sine, of course, is y equals sine x. And it's transformed to the new one. So I'm gonna make a copy here. Right, so just put it here. And now you can see there's undergo a lot of transformation from the original one to the current one. So we're gonna try to analyze what kind of transformation is done. So recall the way I do is I will make whatever the original one is x0 to y0, and then that's actually a point on the original function is called x0, y0, and the new point is called y, called x and y. So we try to establish what kind of relation between x0 to x and then y0 to y. So let's make pi over 3 x plus 2 equal x0. And then if you do this, so the current function will become y equals negative 3 sine x0. See, everything here turned into x0, and then of course you get sine x0 plus 1. And you can tell sine x0 is exactly equal to y0. So this one is simply becomes negative 3 y0 plus 1. Okay, now isolate the x here from this equation. Isolate the x. So you divide by pi over 3 and then minus 2. So let's cut 2 steps. So if you times divide by pi over 3 on both sides, right, and then the equation is going to become x plus 2. Let's still use the original color. So it becomes x plus 2 plus 2. So x plus 2 equals x0 divided by pi 3, right? And then moves x plus 2, and then you're gonna subtract 2 on both sides. Okay, so then it becomes x equals x0 divided by pi over 3 minus 2. And then the y equals, I also bring it down to put them together, negative 3 y0 plus 1. Okay, if you look at this, you can tell that's the transformation done from the original y equals sine x transform into this. So we got the new x equals x0, the old one, divided by pi over 3, then minus 2. And so if you look at this, that really means for any x, it's gonna first divide by pi over 3 and minus 2, then minus 2. So then you can think about whatever the point originally on the y equals sine x, we always have this kind of operation to produce a new point. So then you can tell, the original period is the period t equals 2 pi for sine x0, sine x, right? And then the new period is because all the x is divided by pi over 3, so you can see the new period t prime. See, it should be use the original period t divided by the pi over 3. Okay, so that's we can actually calculate what's the new period for the new function. So 2 pi over 3. So you should get 6. Okay, now we can actually label a couple points. That means the function is going to be starting from 0 and then end up at 6 for one complete term. But be careful, because we minus 2 here. That means all of the point on the new function is going to minus 2. So that means we should start our graph from here. Okay, start the graph from here and then end up at point 4. And you know the graph should look like this. Going up, come down, and going down, then come back to this. So obviously this is going to be another point the function is going to pass, right? Okay, so but we don't know how high it will go. Okay, now that's about the transformation on the y-axis, the vertical direction. So look at this. So the new y equals -3 times the original y, and then plus 1. So we know when you times -3, so you could think as 2 steps. The negative sign means everything is gonna reflect about the x-axis, so it's flipped vertically. Okay, so and then times 3. So that means you should have it go up to 3. Okay, but another thing, don't forget, you plus 1 after you do this. So that means eventually this point is gonna be +1. So we should start from here, because every point is go 1 up, and then it's supposed to go up, and then it's go down, right? Because it's a reflection there. So we should have this point in the middle and going down 3 units. So 1, 2, 3, it should end up here. Okay, and then come back to this point, and then from the middle you should count 3 up, right? So the 3 up is actually the vertical expansion from originally 1 to 3. Then come back to here. Okay, so now we can try to sketch. So it's not easy to do a good job, but I'm trying. And keep going. Oh, it's not very nice. So I'm going to erase this part. Okay, the tricky part is if I erase, it's also going to erase the grid. So okay, it's not too bad. So that's one complete one. So we can actually verify. Now, if you've done, normally I always recommend the students to verify what you have done. For example, so to verify, you try to make some points. For example, this point on the graph. So that's the point when x equals -2. That's plugging here. So -2 here, plugging, you got 0, 0 times is still 0, so sine it would be 0, you get a +1. Okay, so we got it done. And this point is look like 0.5. Let's try this. So if you put 0.5 here, so then 2 plus -0.5, you got a 1.5, and 1.5 divided by 3. So you should get 1 over 2. 1 over 2, and 1 over 2 times pi, that's 90 degree. You should get +1. And when you get a +1 times -3, you get a -2. That's exactly true. Okay, so if you want to try other points, you can do this similar way to verify. Anyway, for this kind of question, if you look at how I did it, I really think about the concept of transformation, right? From the original function transfer to the current one. So to be able to do this kind of question, the first thing is you have to be very familiar with the original function, original graph, and how is the graph going up and down, this kind of thing. Okay, so yes, that's it.